Okay, so yeah, so there is a very high chance that one of the problems, one of the 6 FRQs will be a slope field one, and it's usually on a non-calculator section, okay? All right, so take a look at this one. A type of medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by the function y equals AT. So AT is the amount of the medication, t hours later. And it satisfies the differential equation dy dt is, that one. So that's the rate of change of it. At time t equals 0, there are 0 milligrams of medication in the patient, right? So that's your initial condition, right? So y of 0 equals 0, or you can say a of 0 equals 0, okay? All right, part A, a portion of the slope field for this differential equation is given below. Sketch the solution of the curve through the point 0, 0, okay? So this is where lots of times, like especially in the very beginning, students kind of get bogged down by the specifics of this, and they want to be sort of like NASA precise, and you really can't be as precise. But what you want to take a look at, so rather than concentrating on like the graph point by point by point, what I would like you to do is I want you to step back, okay? Step back. What do you feel like the trends are of this curve starting from this corner right here? Show me with your hands. What do you feel right? There's this sort of, like it's increasing and then flattening out. So what you're going to do is you're going to draw something that looks like that, following these little, slope fields or slopes as a guideline. So I kind of do it with like a, a motion, right? And look, okay. Do you see that? Okay. So they go up and then they start to level off. All right. Okay. Next, using correct units, interpret the statement, limit as t approaches infinity, a of t is equal to 12. Okay? So what do you think that means? What do you guys think? The limit as t approaches infinity of a of t is 12. What was a of t?
1.
Right, but what did it stand for? The amount of medication. So, a large number of hours later, right? Like after many, many hours has passed. So when you say t approaches infinity, this is how much the medication lasts in the body. So this is not like, right, like the time here and the time in like radioactive decay are very different scales, right? We're not talking about billions of years here, right? Not that infinite amount of time, but an infinite amount of time in the life of this medication, right? So it's like, 10 hours, 12 hours, 24 hours, whatever, right? So you're not going to say as, like an infinite number of hours have passed. No. So basically, like, as many hours have passed, after many hours have passed, the amount that is left in the body is how much? 12 milligrams, okay? After several hours have passed, several or many hours have passed. So they're not going to dock you on like the adjective that you use here for the hours, okay? You need a packet, right? Okay. There are 12 milligrams of the medication remaining in the body. Okay? Use separation of variables to find y, the particular solution at 0, 0. Okay? So, all right. So separation of variables. Here we go. Everything with the y has to go on this side, right? So we're going to divide by 12 minus y. So it's going to be 1 over 12 minus y dy is equal to 1 over 3. That's what's left there, dt. Now I integrate and I integrate. Okay, the left side, I have to integrate using u substitution, right? You can do it without, if you do the chain rule properly, but let's just see how it works out. U is 12 minus y. Du is negative dt. Sorry, negative dy. Okay? So this is negative 1 over u du is equal to 1 over 3t plus c. So here, this is negative ln of u equal to 1 over 3t plus c. This is negative ln of 12 minus y is equal to 1 over 3t plus c. Okay, let's put in the initial conditions. At t is 0, y is 0. So this is negative ln of 12 is equal to 0 plus c. So c is negative ln of 12. Okay? Now, I go back and I put the c in this step right here. So this is going to be negative ln of 12 minus y is equal to 1 over 3t minus ln of 12. Okay, and so look at what I did here. You had 12 minus y inside your ln, okay? But this is happening when y is 0. That means the stuff inside the ln is going to be a positive 12, so I no longer need the absolute values. Okay, so I can take them out, away. Okay, now multiply through by a negative. So I get ln of 12 minus y is equal to, okay, so these are going to be minus and plus, right? So it's going to be ln of 12 minus 1 over 3t. Raise everything as an exponent of e. So 12 minus y is e to the ln of 12 minus 1 over 3t. And so what does y equal to? 12 minus e to the ln of 12 minus 1 over 3t. Okay? Yeah.
So we went from negative ln 12 equals 0 plus c
at
the bottom. So how do we, for the next step, get 1?
So this means c is negative ln of 12. Okay?
Okay.
So I took that c and I plugged it in here.
Oh, okay.
Okay? All right. Okay, now, a different procedure is used to administer the medication to a second patient. The amount in milligrams of the medication in the second patient is now b of t that satisfies this new differential equation. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Okay? So that's the initial condition there. It's 1 comma 2.5. Okay? Is the rate of change, okay, so here's the question now. Is the rate of change of the amount of medication in the second patient increasing or decreasing at t equals 1? So, is the rate of change, where is the rate of change? This. Is it increasing or decreasing? Okay, so now, let's talk about this. Suppose you have a function f of x. How do you know if it's increasing or decreasing? Huh? If the what? Right. So f of x is increasing if f prime is positive. Okay? So let's generalize that. Any quantity is increasing if its derivative is positive, right? Any quantity. So now what is the quantity that we want to look at? dy dt. Okay, we want to see if the rate of change is increasing. dy dt is increasing if its derivative, d squared y dt squared, is positive. So this question is testing you on that relationship. Any quantity is increasing if its derivative is positive. So what we have to do is take a derivative of that. So we need to take d squared y dt squared. Okay, now let's take a derivative of this. Okay, what's the derivative of 3? 0. So we basically have to take a derivative of this piece now. This piece right there. Okay? And I'm going to take and I'm going to put like the negative with the y. So let's do low d high. Low d high negative dy dt. Take high d low 1. Cross the line and square the low. Okay. So all I want to know is this positive or negative at the point 1, 2.5. So let's evaluate this. 1, 2.5. Okay. So t is 1. And then y is 2.5. Okay? So the first one, we get 1 plus 2, 3. Oh, negative dy dt. How much is dy dt at this point? We haven't evaluated that, so let's do that here. Dy dt, evaluated at 1, 2.5, is 3 minus 2.5 over 3, 13 over 6. So I'm going to put that here, but it's negative 13 over 6.
What did you plug it into? Like what did
dy dt. Look, dy dt here. Right, dy dt. Okay, so plus, what else do we have? Y is 2.5 times 1 over 3 squared. Okay, so how much is this? This is negative 39 over 6, which is like more than 5, right? And then plus 2.5. So this is a negative over a positive. So this is less than 0. Okay? So you say, give reasons for your answer. You say, since d squared y dt squared is less than 0, dy dt is decreasing. Fish enter a lake at a rate modeled by the function e given by this. Okay, so e for enter, get it? Fish leave the lake at a rate modeled by the function L for leave. And look at these complicated functions. You are not doing anything to these functions by hand. These are meant for you to graph them, okay? Both E and L are measured in fish per hour. You never thought you'd see that as a unit anywhere, right? And T is measured in hours since midnight. And look at how nice they are. They tell you that midnight is T equals 0, okay? Okay. How many fish enter the lake over the 5-hour period from T equals 0 to T equals 5? Okay, so for this, we're going to integrate. Look at what we're going to do. How many enter the lake? We're going to integrate from 0 to 5, e of t dt. Okay, so let's go ahead and put that in our calculator. Okay, so it's going to be 20 plus 15 sine pi x over 6. Okay, there we go. And we don't really care what it looks like at this point, but we're going to go here, and now we're going to integrate from 0 tab 5 tab f1 of x. dx. Okay, and that's what we get. 153 0.458. Okay, so it's 153.458, but you want your answer to the nearest whole number, so you're going to say 153 fish. That's it, just that many fish. In those 5 hours, 153 fish have entered. Okay, so for this, I do have the rubrics of how they were scored that year in 2019, and you get 1 point for the correct integral and 1 point for the correct answer. Okay, so 2 points for this. Now, what is the average number of fish that leave the lake per hour over the 5 hour period? So average value, right, is 1 over 5 minus 0, 0 to 5, that leave the lake, L of t dt. So for this, you're going to plug in L of t in F2. F2, what is L of t? It's 4 plus 0.2 to the power of 0.1 t squared. Oh. Did you put in a variable? Here you go. Okay? So, did I do that correctly? Yes. Okay, so when you go back, recall this function again, right? And now you want to do F2, okay? So just edit it. But in the front, you want to do 1 over 5. So that's this many.
Do we not have to write the equation, I mean, like on the paper, do we not have to handwrite, like, average?
No. So, okay, so let's see. What is the largest number? What is the average number of fish that leave the lake? Okay, so this is equal to, what was that number? 6.059 fish per hour. Okay, and again, you get 1 point for the correct integral, 1 point for the answer. Okay. Well, because this was the average number per hour. Here we divided by 1 over 5, right? This is just the integral. It gives you fish. This is fish per hour. Okay? Okay. So at time t equals 0, oh yeah, go ahead.
So we only round specifically if it says,
Mm-hmm.
even though this.
Yep, exactly.
Okay.
Because it does make sense. It's on average, right?
Okay.
6.059. So if you say on average, 3.5 students enter my room per hour, over 2 hours, that's 7, right? If you didn't give the 0.5, it would be 1 less over 2 hours. Do you see that? Yeah. Okay, at what time t from 0 to 8, Eli, was that your question?
Oh no, I was gonna ask if I wrote 6.059 fish and I forgot
The per hour?
Would that be the point off the answer?
So in this case, it looks like they didn't give specific points for the unit, but if they had awarded points for units as well, and usually it'll tell you, like, give the answer with units, and if you give the incorrect units, then yes, you lose a point. At what time t from 0 to 8 is the greatest number of fish in the lake? The greatest number of fish in the lake. Let's talk about this one. We have the rate that fish are coming in. We have the rate that fish are coming out. How do you figure out how much is in the lake at a time? So for example, yeah, so like if 7 kids enter and 2 leave, how much is in the room? If 7, 5, what did you do? You subtracted, right? So if you have the rate that people coming in and the rate of people leaving, the rate of the number of people in the room is the difference of the two, okay? So Okay, so C, oops. So basically, E of t minus L of t is the rate of change of fish in the lake. Okay? So this is the rate at which they're coming in. This is the rate at which they're leaving. The rate at which the number of the fish in the lake is changing is the difference between the two. Now, what we want is the greatest number of fish in the lake. All right? So what we want to do is when is there more fish in the lake? So let's see what we're going to do here. Let's look at the graph. Okay, this is all happening between 0 and 8. So let's just look at that part of the graph from 0 to 8. Window settings. Let's go from 0 to 8 here. Okay? And let's make the y values a little bit bigger. I'm going to go to like 165. Okay. All right? Okay. So look at what happens. E is the number of fish entering E is the rate at which fish are entering. L is the rate at which fish are leaving. So do you see how until this point, more fish are entering than leaving, right? Or fish are entering at a faster rate than are leaving. But then after here, you see that the fish start leaving at a greater rate than they are entering, right? The rate at which they're entering is less. So if they kept entering at a greater rate than they were leaving, then you were accumulating more and more fish here. Until about this point, when that changed and more fish started leaving. Think about it, right? Think about it. Like more and more are leaving and only more and more are coming and only a few are leaving. And then there was like this mass exodus of fish. They're like, we're done here. We're leaving, okay? So let's figure out where that point of intersection is. Menu, analyze graph, intersection here. This is at 6.20356, okay? So the rate is equal to 0 at t equals, what was it? 6.204. Okay? That means, okay, so if this minus this is 0, that means they're equal at this point. Okay? And now you kind of have to say, like in words, what's happening here. Okay? So E of t is greater than L of t on 0 to 6.204, right? And E of t is less than L of t on 6.204 to 8, okay? Therefore, the greatest number of fish is at t equals 6.204. Okay? Okay. Is the rate of change of the number of fish in the lake increasing or decreasing at 5 a.m.? The rate of change of the fish is ddt of E of t minus L of t. Huh? Sort of, but you still have to kind of show it at t equals 5. Yeah. But you're going to see that it's not increasing, it's decreasing. Okay? There's a little bit of a thing here. So the rate of change of the number of fish in the lake, is it increasing or decreasing at 5 a.m. t equals 5? So this is the derivative of this, right? So it's going to be e prime of t, or actually it's at t equals 5. So e prime of 5 minus L prime of 5. Let's see how much that is. Okay, so what's e prime at 5? Menu, analyze graph, dy dx of this graph at 5 is negative 6.8, right? What was it in the full? Negative 6.802. I'm going to do it like this. Minus, what is it over here? So menu, analyze graph, dy dx, this graph at 5 is, what is that? 3.92. Okay, so together that's negative 10.7228, which is less than 0. Therefore, the rate of change of the number of fish is decreasing. Okay, this doesn't mean that the amount of fish is decreasing. It means the rate of change is decreasing. That means the rate at which the number of fish was increasing, they're not it's increasing slower. Do you see what I mean? That's what that means. The rate of change is decreasing, not the number of fish. The number of fish is still increasing. Okay? Okay. Because remember, E of t is rate. E of t is rate, and L of t is rate. So when you do ddt of this, this is the rate of the rate. Okay? So for example, like if you start, I don't know, like if somebody is growing, right? Let's say like at one point they were growing like, I don't know, an inch a month. I know that's ridiculous, right? An inch a month. And then at another point, now they start growing an inch every 2 months. They're still growing, but at a slower rate. That's what we're doing here. Okay, let's move on to the next one. This is like the one we had done yesterday. Oh, let me tell you about points here. So there is one point here to show that, basically like comparing where they're equal to each other. 1 point for the answer and 1 point for the correct justification, right? So basically, if you do this and get 6.2.04, you got your 2 points. And even if you mess up on the correct wording, you can get the 2 out of the 3 points here, okay? And then here, you get 1 point for like looking at the derivatives of this, and then 1 point with the answer and the explanation. Okay? So suppose you do A, B, C, and like you get to this point, and you're like, I really have no clue. That's 2 out of the 9 points, which is really not that bad. Okay? All right. So let's go here. The velocity of a particle P moving along the x-axis is given by the differential function Vp, where Vp is measured in meters per hour and T is measured in hours. Selected values are shown. Particle P is at the origin when T is equal to 0. Okay? So x of 0 is 0. Okay? The position is at 0. Justify why there must be at least one time for which V prime of t the acceleration of the particle equals 0 meters per hour. Okay. So where do they get this from? So this is between 0.3 and 2.8. Look at this. Do you see how if you were to find the average rate of change between 2 points, what would it be? If you do y2 minus y1 over x2 minus x1, since the y's are the same, it would be 0, right? Yeah? So this is, look, justify y, there must be at least one time in which v prime of t is equal to blah, blah, blah. Does this not sound like the mean value theorem that we were talking about yesterday? If the function is differentiable and continuous, then there is at least one point where f prime of c is equal to f of b minus f of a, blah, blah, blah. So that's, the wording lends itself to that. So, what is VP? Okay, so what needs to happen for that to take place? It has to be a continuous function. Well, you're told that this is differentiable, okay? So you say, since VP of t is differentiable, okay, it means it is continuous. Since it's differentiable, comma, it is continuous. Okay? Therefore, by the mean value theorem, there is a point where v prime p of t equals, now you have to show what it equals. Basically, v of 2.8 minus v of 0.3 over 2.8 minus 0.3, and that's equal to 0. Okay? You don't have to show like you putting in the 55 and stuff. So for this, you get 1 point for showing this, and 1 point for saying all of this stuff. Okay, all right, next one. Use a trapezoidal sum with 3 subintervals to approximate this. Okay, so 3 subintervals. All right, so here we go. From 0 to 2.8, this is going to equal, okay, so how do we do this? So remember what the trapezoidal rule is. It's the height, which is 0.3 over 2 times b1 plus b2, so 55 plus 0, plus the other one is, what's 1.7 minus 0.3? 1.4 over 2, negative 29 plus 55, plus 1.1 over 2, 55 minus 29, that's all basically, right? And that's 40.75. And this whole thing is just 1 point. Okay, so basically you have to do it correctly and get the correct answer. If you do this correctly but get the incorrect answer, it's wrong. Okay, a second particle Q also moves along the x-axis so that the velocity is given by VQ now. Find the time interval during which the velocity of the particle Q is at least 60 meters per hour. Then find the distance traveled by the particle in that interval. Okay, so first you want the velocity to be 60 miles an hour. So go ahead and plug that into your calculator. You want VQ of t to equal 60 miles an hour. So let's quickly plug that in. Okay, so how much is that? 45 root x cosine 0.063 x squared. Oh. Okay. So that's how that looks. And you want it to be equal to 60. So in the second part here, you want to put in 60. And if you go to menu, window, zoom, you want to go to like somewhere higher than 60 here. Maybe let's go to 75. Okay? So that's where it crosses. So you want to find the points of intersection there. There are 2 points of intersection, 1 and 2. So the first point is at 1.886. So you say this is equal to 60 at t equals 661 or 662, and t equals 3.5191 or 92. Okay. Okay, and I think I watched like a webinar or like a video of like the AP board solving this, and I put a note here that students got no points if they only put 2 decimal places for this. Okay, then what you want to do, you want to find the distance traveled by the particle during this time. So if you want the distance traveled, that's the absolute value of VQ of t, but dt, you want to go from A to B, okay? So you want to go from A to B. So you want to store these in your calculator, right? And maybe we can pick up from here. But you have to first write here, let A equal this number and let B equal this number, okay? And you store them in your calculator and you go ahead and do that. So for tomorrow, go ahead and finish this one, C, and try to do D as well, okay?